Good morning. In today's class, let us see how a combinational logic way can be derived using the problem statement. With the first technique, let us discuss while designing the combinational circuits. The first technique it is conversion of problem statement to truth table. To start with, before any combinational circuit, circuit design, it must be defined that is proper statement to proper statement of a problem. So whenever a truth table or problem statement it is given, so first let us see how to convert into a truth table. This complete conversion process it is we are able to understand through a systematic diagram. That diagram represents the initial state as the problem statement. Converting this problem statement into an truth table construction by constructing a truth table, then we need to go for switching equation derivation from truth table. We will be writing switching equation, later step. Then these equations needs to be simplified. So in continuing with that, such a equation, once we derive these equations after simplification, construction of logic diagram will be done. Finally, from that logic diagram, a logic circuit will be built. This logic circuit during the construction, it may be using the TTL technology or ECL technology or using CMOS technology. The logic circuit can be designed. So this diagram depicts the sequence of design tasks in a general way. Now with this fundamental, let us go for the first problem statement, how to convert. We have a problem statement. The first problem statement is like this. An electric motor powering a conveyor used to run or used to move material which is to be turned on when one of the two operators are in position or if material is present to be moved and there is a case if the protective interlock switch is not open, so for which design a combinational logic truth table. So this is a problem statement which has been given. To support to this problem statement, we have the diagram also, wherein this diagram represents the complete statement in the form of diagram. So you have a roller. This roller, it is placed on conveyor belt. In between, we have a switch to so this will be the switch. In between this, there is a light sensor switch. It is represented as S. And on the conveyor belt, we have a material M, which is represented as a small m. And the conveyor belt is monitored by two operators. Those two operators are represented through two variables as operator 1 and operator 2. There is a conveyor belt movement which is under the control of the motor. So this motor, it is represented through capital M, and this is the diagram which has been used to illustrate the above problem statement. Now, for this particular problem statement from the diagram, the truth table has to be defined. So how the truth table it has to be defined? For that, you have to analyze the given statement thoroughly. So you have an electric motor which is powering the conveyor belt, and this is used for the movement of the material, and this motor has to be turned on subjected to conditions. Out of two operators, one operator must to observe the conveyor belt or must be present near the conveyor belt. Along with that, the material has to be presented on the conveyor belt, and the switch also has to be closed. If the switch is open, the motor should not turn on and the material should not move. That is the first condition. The second condition, if operators are not present, material should not move and motor also should not turn on. So with this, now let us see how to construct a truth table. So during the construction of a truth table, we should have the input variables as well as the output variables. When you look at this diagram, first let us separate the input variables and the output variables. Input variables, one is the switch, the material, operator 1, operator 2, and also these are the input variables. And output variables, if you look at, it is only the motor. Okay, so now if you are giving a relationship between the input variables and the output variables for the given problem statement, output M is a function of the input variables. It is operator 1, operator 2, material, and switch. If you want to replace this operator 1 and operator 2 through the variables A and B, you can represent through another variable. Hence, after consolidating all the variables, now you can construct the truth table. If the truth table you are constructing, it is the first I am taking the operators AB, then I'll go for the switch status and I'll go for the material, and these are as inputs and output variable as M. Since there are 4 variables in the input, so let me give the combinations on each of these input variables 00s starting from 000 to 1111 as 000, 0001, 0010, 0011, 0100, 0101, 0 1 1 0. The next combination is 0 1 1 1, then 1 0 0 0 1 0 0 1 1 0 1 0 1 1 0 1 1 0 1 1, then 1 1 0 0 1 1 0 1 1 1 1 0 1 1 1 1. Now after this may be the variable a b, then switch status and the material status, which are in the input columns of the truth table, and the output it is M. When you start filling the output variable, so the first combination it illustrates the material, the motor, whether to turn on or not. If it is observed, the first combination 0 0 0 means there are no operators, which is open, even material is not there. So in that case, the motor should not turn on. The material exists, switch is not open, operators also are not there. So our motor should not turn on. Similarly, when we go for switch in this particular combination, operators are not there, switch is closed, whereas material is not there. Then also conveyor belt should not be turned on through the motor. In the next combination, switch is closed, motor is closed, material is available on the conveyor belt, whereas operators are not there, so motor won't turn on. One operator exists, but switch is open, material is not there, so motor will be in off state. One operator exists, whereas switch is open, material is existing, then also the motor should not turn on the conveyor. One operator exists, switch is closed, whereas motor is off. Material is not there. In that case, also the motor should not turn on the conveyor belt. If you go for the next combination, one operator exists, switch is closed, interlocking switch is closed, and material exists. So all the conditions have been satisfied. So hence output bit should be 1. In the next case, material not there, interlocking switch is open, one operator exists, then also motor should not. In the next case also, one operator and material, but switch is not closed, so therefore motor should not turn on. Switch is closed. In the next combination, operator exists but material not there, so motor should not turn on. The next combination, one operator, switch is closed, material, so therefore here we need to make the motor to turn on. And if the next combination is considered, two operators, interlocking switch, it is open, and material exists but 0. So here in the next combination, two operators exist, which is closed, material is not there, so therefore motor should not turn on. The last combination of the truth table, if you look at minimal requirement for an operator to exist at the conveyor belt is 1, but both the operators are available. Material is available, switch is closed, so therefore motor should be turned on. From this truth table, in the as per the process flow diagram, if the switching equation is derived, it is a function of A, B, S, M. How do we derive it? So for that, need to go back to the previous. So here in this case, which are the combinations 1 exists we need to consider. So in the first half of the table, there is no output 1, and if you go for next half table, there are combinations of the input which is able to provide an output 1. So we have to consider those output 1 as we are representing the combinational circuit through the sum of product terms. The very first term, if it is considered, the first output 1, it is for the input combination where A is 0, B is 1, S is 1, M is 1. So therefore, A bar, B, S, M. This is the one combination of the input which is making the output of 1, or there are other combinations also which includes A, B bar, S, M, or another combination it is A, B, S, M. So this is how you can convert an given problem statement into an truth table. Yes, students, in the next class, we will discuss how a switching equation, if it is given, we can simplify, or how we can remove the redundancy amongst the switching equations using Boolean logic.